like two.
Yeah, sharing. Not big on sharing, Kyle? Farouk?
Why didn't you do that over there?
Because we needed a structure that had 20 electrons. This had more electrons to bring in. And then with single bonds, it already has 20. So yeah, you don't have as many electrons here as they wound up having to share. Okay?
We're still not there.
Yeah, we're not there yet. If you count them up now, we've gone down by 2 electrons, down from 20 to 18, but we need 16 electrons. So what are we going to do now?
Same one
Make
on
another
that
double
side.
bond over here. But could I make a triple bond here?
No.
Why?
It's way too unbalanced and unstable.
Unbalanced? I'll give you that. It is an okay dot structure if you put a triple and a single. That's fine. But it's more likely that we're going to have this. Double.
Carbon's like a mom and holding on to its two kids and sharing everything. Just like
His
mom.
two
Yeah, it's
kids
like the mom that has to share. Count them up, there's 16 electrons. That's our structure.
with his 2 kids.
Her. Yes.
Does it matter which one you take away? Because for that O, you took it from the bottom.
No, I just did bottom there and then top there, but it doesn't matter. Just make sure you erase one from each atom, one pair of electrons from that. Yeah, good question. Now the next one is the ClO4 -1 ion, a polyatomic ion. Cl and O are both nonmetals, so even though there's a polyatomic ion, it's made up of nonmetals, therefore the bonding between those two is covalent bond. How does the dot structure for ClO4 look? Well, same as always, we're going to count the number of electrons in this thing. Chlorine has how many?
7.
There's 4 oxygens, each having 6. And then what about that -1 charge? Add an electron. Right, don't fall into a trap where you're subtracting
Wait,
electrons.
onto oxygen or what?
Onto the whole thing. You're going to have to account for 1 more electron than just the Cl's and the O's.
Oh, okay.
Provide. So 7 plus 24 is 31 plus another one is 32. Yeah? Which one's in the middle?
See.
The oxygens won't ever go in the middle, unless it's like water. So you put the Cl in the middle, which is kind of weird too, because chlorine only has 1 unpaired electron by itself, but it winds up in the middle of all these oxygens around it. So you're going to put 1 oxygen on around every side of the chlorine with single bonds. 4 kids. Add lone pairs to everybody to get everybody 8 electrons around them. Now in this case, the chlorine doesn't need any lone pairs because it's already got 8 by making those bonds.
That's only 28.
Count them again.
32.
Yeah,
Oh my God.
every oxygen has 8 electrons around it. So it's 8 times 4. Yeah, you just missed some.
Today before spring break, don't worry about it. I added 4, not 8.
Yes, in some cases. Yep. Those valence electrons, they can kind of come out. Even for chlorine, because oxygen is such an electron hog. Okay, now, there's one other thing, and by the way, so we are good. We only need single bonds here. We have 32 electrons. Everybody has 8 electrons around them. That's the number that we need, so it's good. The one other thing I would say about this structure, because this is a polyatomic ion, this whole thing has an overall charge. It's got an extra electron than the atoms provided. When you have a polyatomic ion, you may remember this from last year,
Oh, yeah, pull a bracket
you're going to
out.
put the brackets around it and indicate the charge on the outside of the brackets like that. Do that for the ions only. You okay with that?
Are we gonna make some big elements?
So then we're going to get into some funny things on the next slide.
I call shenanigans on this.
There's no shenanigans. I'm going to leave my step 6 up here. Sulfur hexafluoride, SF6. This one's going to be an oddball. SF6, count the number of electrons. Sulfur has 6. There are 6 fluorines, each having 7 electrons. So 6 plus 42 is 48 electrons.
That's a lot of counting.
That's obnoxious.
Don't do it.
Which one goes in the middle?
Yes.
The sulfur in the middle. It's less electronegative. And that means we need to make 6 bonds to fluorines on the sulfur.
Wait, is that possible?
Just like this. possible.
Okay.
This is a legitimate compound. And so the F's all go on the end of those single bonds.
Wait, is S one those special exceptions that it can create? like
Yeah,
six
because it's in the third row and bigger, those elements can take their valence shell and spread them out and have more than 8 electrons.
Yep.
Okay, so we've made single bonds to all the fluorines. Now, add lone pairs. Bear with me.
Oh, and then you're fine.
You say
Like,
pair
if
with
you-
five
sometime.
Pair with me, yeah.
And both by 5.
Hey,
Six,
this
seven,
no
after
way.
the first 5 points.
Yeah, you're fine.
S.
I got it. I got it.
For the S,
Oh gosh, that's awful.
I like it, Eric. I like it.
Snowflake. Wonderful, you know.
Wait, it is.
Count the number of electrons,
36.
if you feel like it.
48.
Nope,
Plus.
you
It's
forgot
48.
these
It's
bonds.
36 plus.
Oh, plus the bonded ones, yeah. 48 electrons in there, all single bonds. We've got our number of electrons that we need, and that's the dot structure for sulfur.
So
How many electrons are attached to the sulfur here? Valence electrons. There's 12.
Well,
It's made 6 bonds here. So the sulfur is big enough to expand its valence
That's a
level to
lot,
have
kids.
12 electrons on it. Yeah. Okay, then now the next one is the wacky one.
so if you're
Speaking
doing
of wacky, Spencer?
so if you're doing oxidation numbers for that sulfur, would have like a +6 oxidation.
Yes, it would. +6. That's crazy. Yeah. Everybody catch that?
No.
If you're assigning oxidation numbers for SF6, you know fluorine is always -1. It's the most electronegative thing. It's going to take electrons. That leaves the sulfur as a +6. Yep. Do you think this is a stable molecule?
no.
It's not stable because the sulfur is going to be very ready to react. Now, it is a legitimate thing.
Just like a model
And by itself, SF6 does stay SF6, but if you put it with something else, typically it is going to reduce pretty readily. All right. Good call on that, Spencer.
Thank you.
I'll take away my wacky comment.
Oh well.
You do it point as you
No, I guess I don't. Here's a funny one.
Xenon.
XeF2.
Oh my gosh.
Xenon
That
difluoride.
shouldn't
A
happen.
compound that, yeah, that's what I mean. Wacky.
It's already stable on its own.
Yes. But if you put enough energy into it, you can get the fluorines to bond to it.
How much energy?
I don't know. I've never seen any compounds with xenon, but I know that they exist. Yep.
Xenon sounds
So,
like a cool.
well, just humor me. Let's see if we can do the dot structure for XeF2. It is a legitimate compound. I'm not just making this up. XeF2. So, count the number of electrons. Xenon has 8, plus the 2 fluorines, 2 times 7, equals 22 electrons that we're going to need in the structure. Who goes in the middle, the Xe or the F? This is so crazy.
Is there like
Xe is going to go in the middle, and then make single bonds to the F's. Do you notice that we do the exact same thing every time?
Yeah.
Am I encouraging you to do the same thing every time you have one to do?
Yeah.
I think that's implied. Can we just like draw lines instead of dots?
Yes, you can draw lines instead of dots if you want to, for sure. So, I now have added my lone pairs around everybody, and now count the number of electrons that we have. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. I'm slow. There's 20, but we need 22. We need to add electrons.
Double bond.
That takes away electrons.
I knew that. Gary, don't.
That's why I left number 6 up here. If you need more, then you're going to have to add them on. Add them to the central atom. So, Xe already has 2 electrons that are 2 lone pairs of electrons. So,
This is.
we don't like that.
It's like a fat mom.
Wow, that's kind of.
Okay, Kyle, enough with the mom.
Yeah.
It's like so
See, you know, I could like.
This is the dot structure for XeF2. It's got 22 electrons. The fluorines have 8 electrons around them. That has to be. Your peripheral atoms are always going to follow the octet rule. If something's not going to follow the octet rule, it's going to be the one in the middle. I'm picturing it with you, Kyle. Are you up for one more? This one that you just did is the most wacky. Okay, you try the nitrate ion, NO3 with a -1.
Is NO one of those special exceptions again?
it's now.
This one? No. Nitrogen monoxide is NO. Because N has 5 electrons and oxygen has 6. That's an odd number of electrons. And so you're going to have an unpaired electron somewhere
I
else.
remember one, like usually a dot structure has like, the central atom has like 8 around it, right?
Yeah.
I remember there was a rule
Leave.
about one that has only like 4 around it,
No.
or 6.
Boron.
4, oh, boron.
Room what?
Room 210.
Okay.
Okay.
Do I
You
make?
can say 10.
No.
JD.
What's your background on this? You ever talked about it?
So I got the rocket ship.
Yeah.
I didn't say anything about it on purpose.
On your Hawaii.
'Cause it's embarrassing. Oh wait, is it a bridge
It's not the sun from Teletubbies, I guarantee you that.
That is the creepiest
with rope?
looking sun
Oh,
ever.
the picture from IKEA.
What sun?
Wait, what is
End of a tunnel or something. That sun is my hero.
That's
It's
what
like
it
a
is,
rope
Felix.
bridge.
It's a train, it's a train from here.
This is a symbolic.
Oh.
Is it the, wait, is it a railroad?
All year we've been walking through this dark tunnel, and now we start to see the light.
Oh, it's really hard to
Yeah,
see.
that's
It's like
all.
the Underground Railroad.
That's
not what it
very,
actually
very
is.
true.
Yeah.
It got really dark at the beginning.
Thank you for asking that, JD.
Wait. I know good young mama joke.
No,
Absolutely not. Save it, Kyle. Save it.
Okay, you're doing the nitrate ion, right?
Keep it all in the top. It's the insurance that really hurts you.
How's our nitrates? Good?
These are way too easy.
No, that was a little bit
Has 2 extra
Kelly, are you okay? You don't always write left-handed.
You have to put it like a.
Oh,
What?
I didn't know if you had an injury or something.
You have to put a bracket around the outside so makes it warm.
Yes, now hold on. Are we done here with the dot structure?
No,
Nah.
you got 2 extra left.
I've got too many electrons on this. I should have 24 electrons, but when I count them, I've got
Whatever,
26.
get rid of them.
How do I get rid of electrons?
Double bond.
Now, does it matter which one I make a double bond?
No.
Are you sure?
Yes. No, it does matter.
Oh,
No,
yeah,
it doesn't.
Don't take that off.
You have to rotate.
Vesper.
There for.
Yes. No.
How?
Yes, Vesper theory, but that's later.
Yes.
You have to rotate. Yeah, you're starting to think about the shape, aren't you?
Yeah.
Turns out, though, that when you write the dot structure, it really doesn't matter which one you make the double bond to.
Told ya.
Is it okay with you if I make it on the oxygen on the left?
Yeah.
Eric?
Would you have to do like what Spencer did and make it like triangular? Because that's what I
If it's just asking for the Lewis structure, no, you can write it like that. If you're asked for the shape, it might help to write it like that, though. Why did you write it like that? Because the N
Oh yeah, because it's only
has
3
its
of us.
orbitals spreading out to be as far apart as possible from each other. That's called Vesper theory.
21, 21, 20.
And yeah, that would be a 120-degree angle.
SB2?
Yeah. Now I got one other thing to tell you. A double bond is a little bit shorter. It brings the N and the O a little closer together
It
than a
can't
single
bend.
bond does. Single bonds are the longest bonds, and then double bonds are a little shorter, and triple bonds are even shorter than double bond. When NO3 is analyzed, and by the way, you were right, one of you said, hey, don't forget to put the -1
Yeah, that was
with the
me.
brackets, that's right.
Then what about the other?
When this is analyzed, and its bonding is inspected with a spectroscope, what we find is that all 3 of these bonds are the same length.
What?
That's weird.
No way.
How can they be the same length if one of them is a double and the other 2 are single bonds?
Is it because that
President.
second bond?
The neg.
Okay, Spencer.
It's because, you got organic chemistry, right, Spencer?
Yeah.
It's because of this.
I would have never.
I put the double bond on the oxygen on the left. I didn't have to. I could have put it on the one on the bottom. If it's all right with you, I'm going to leave the lone pairs off.